Today, we're going to talk about a danger that's lurking in the one place we're supposed to feel the absolute safest, a hospital. And it's a threat you can't even see, hiding in something we all use every single day, the water.
I mean, just think about that for a second. You go to a hospital to get better, right? But what if the very water flowing through the pipes could actually be a real risk? We're talking about a nasty little bacterium called legionella, and its story is a lot more common and, frankly, more dangerous than most of us realize.
So, to really get a handle on just how big this problem is, we have to dig into the data. And what that data shows us? Well, it's a crisis that's been quietly building for decades, literally right under our noses.
Okay, this number is just wild. Since the year 2000, the number of reported cases of Legionnaire's disease, which is a really severe type of pneumonia caused by this bacteria, has shot up by nearly 9 times. This isn't some problem that's fading away. It's actually getting worse and fast.
So the story really starts back in 1976. This bacteria first made headlines after this mysterious, deadly outbreak at a convention in Philadelphia. But since then, and especially over the last couple of decades, it's become this stubborn, growing threat. And healthcare facilities, they're a major hotspot. You've got vulnerable patients and these huge, complex water systems. It's just a perfect storm. And believe me, this isn't just a problem in one or two places. A massive global study found Legionella in over 41% of hospital water systems. I mean, that's almost half. The danger isn't just a possibility. In a ton of places, it's already there. Okay, so that begs the question. If we've known about this bug for decades, why is the problem getting worse? Well, it turns out that the old school ways of fighting it, they have a really big flaw. The main villain in this whole story is this stuff called biofilm. The easiest way to think about it is like a slimy, microscopic shield that builds up inside the water pipes. Bacteria, including our old friend Legionella, can just burrow deep inside this shield, which makes them incredibly hard to kill with disinfectants that just kind of wash over the surface.
All right, so let's break down why the old ways just don't cut it. On one hand, you've got the superheat and flush method. You're basically scalding the pipes with insanely hot water. But it's a temporary fix at best. Some bacteria can even become resistant to the heat, and as soon as things cool down, boom, they're right back. Then you have standard chemicals like chlorine. They just aren't great at punching through that biofilm shield. They can eat away at the pipes, and they lose their punch in the exact kind of warm, stagnant water where Legionella loves to hang out.
And this quote from the EPA really says it all. Nothing, no approach has been able to get rid of this thing for good. The bacteria always find a way back. It was pretty clear that we desperately needed a whole new playbook. And that brings us to what could be a real breakthrough, a totally new method that doesn't just try to blast the bacteria away, but actually changes the very water they're trying to live in. It's called mineral oxychloride. And here's the key difference. Instead of a one-time shock treatment, this is a continuous 24/7 thing. It uses these energized oxygen molecules that basically tear bacteria apart on contact. So it creates this hostile environment for germs that's stable, lasts a long time, and, this is a big one, it's gentle on the pipes. So to see if this new approach really works, researchers tracked 2 key things. First is something called ATP. The simplest way to think about it is as a life detector for the water. It's like doing a head count of all the living microbes. The goal is simple. You want a super low ATP number. That means clean water. The second thing is called ORP. Think of this as a power score for the water's ability to disinfect itself. A high ORP score means the water is a powerful germ fighter. So just to recap, what we want to see is low ATP and high ORP. That's the winning combo.
So, how's it actually used? It's surprisingly simple, really. The solution is just injected right into the building's main water line. From there, it just circulates through the entire system, protecting every single tap and every shower all the time.
But the big question is, does it actually work in the real world? Well, let's look at the results from a huge study that involved over 105 hospitals and care facilities. This is where things get really, really interesting.
So here's our before picture. At the very start of the study, almost 80% of the water samples had really low disinfection power, a low ORP score. That means the water was basically a 5-star resort for bacteria. It had almost no ability to clean itself.
And now here's the aftershot. Just 6 months later, bam, the numbers totally flipped on their head. Now, 78% of the samples had high disinfection power. The treatment had fundamentally changed the water itself, turning it from a welcome mat for germs into an active, self-disinfecting environment.
So, what about that microbial head count we talked about, the ATP levels? Well, before the treatment started, a full 40% of all the water samples were just teeming with high levels of microbial life. That's a clear sign of a really widespread problem.
And here it is. This is the number that really matters. After 6 months of this continuous treatment, fewer than 1% of the samples showed that same high level of microbial activity, a drop from 40% to less than 1%. The bacteria were, for all intents and purposes, gone.
So, what does all this mean for the future of keeping our hospitals safe? Well, the implications are huge. It suggests we might be looking at a major shift in how we manage these critical water systems.
So when you put it all together, the takeaways are crystal clear. This method wasn't just effective, it practically wiped out microbial activity. It's stable, giving that round-the-clock protection. It's also super efficient. We're talking 1/10 the concentration of standard chlorine. And, critically, it helps hospitals meet all those tough safety standards they have to follow.
When you look at all the evidence, it's hard not to wonder if this is it. We might finally have a long-term, reliable answer to a problem that's been putting patients at risk for almost half a century. A solution that isn't just another temporary fix, but a real, fundamental change that turns a hidden danger into a source of safety.